But first, Andrew Hately's around here somewhere. I saw him. There he is in the back. And he is also with IBM, and he is going to talk about one of the topics that just came up. And I can just hand wave and say, microservices, you need them. He actually has a little more in-depth information about that. Oh, geez, he does have a costume. You weren't kidding. Okay, let's just do it, Andrew. I didn't think you were serious.
All right, good morning. How's everyone today? So my job today is to talk to you a little bit about some hype going on in the industry. And I was actually told to tie it in, I'm supposed to talk about evolution today. And now, some of my colleagues had told me there was a speaker costume contest. Now I'm looking around the audience, and I'm actually thinking that they might have played a small joke on me, but that's all right. So, happy Halloween, everybody. It's awesome to be here in San Jose. It's always fantastic to actually get to go to a conference and not get on a plane to get there. So I wanted to share with you a couple thoughts on this. So how many people here heard the term microservices? All right, there's at least 2 hands that didn't go up, so I actually have something to share then. No, but I mean, it's been one of those things, just like cloud, just like, back in the day. I actually remember presenting at one of the first SOA conferences, which I think preceded this one. So, we've ridden this hype cycle before, right? And this is kind of an interesting spot to be in right now, because one of the things that we've learned a lot about is that in the evolution of cloud, a lot of sort of point technologies have come up. But the neat thing about microservices is we've actually kind of turned this corner where when we talk to people about how are you adopting cloud and how are you going to actually do something at scale, this is kind of the collection of technology that has come together, right? And we're actually turning this point now where 3/4 of you in the room, it's cool, like all but 3 people put their hand up, but 3/4 of the people we talk to now say, you know what, not only am I doing cloud and I'm fully on board there, that number is up around 100% now. Now it's getting to the subtlety of how are you doing it, right? How are you going to adopt cloud? Now this thing's actually noisy and probably picking up, so I'm going to actually take this off for a bit. But we can actually come back to the dinosaur costume later if you want. So the neat thing about microservices and where we're going is it really isn't necessarily about the technology anymore, right? This is not about, gee, I'm gonna just pick up the next cool thing and I have to do this because I read about it in a Gartner report or Forrester told me to do it or everyone else in my industry is doing it. The drive behind cloud and the drive behind microservices is actually about being competitive and actually putting yourself in a position to leverage the technology we have today. I think everyone in this room could probably agree there's some pressure on you for rapid delivery. There's some pressure on you to figure out how to leverage public cloud. No one's going to get an extra several $100 million, except for maybe John and some of my colleagues, to continue to build out capital-intensive data centers. But the last one's tricky. How do I achieve the first 2, but set my business up to be able to scale? And that's where a lot of what we built in the past, it was built to scale. We could really build it big. We could build it vertically, and it was a beautiful and wonderful thing. But what it wasn't built for was that change and rapid delivery and changing the scope of what the application was supposed to do. Most of those things aren't designed for public cloud. Public cloud, as you probably heard many times over, is great at giving you horizontal scale. It is not necessarily the best spot to go rent a vertically scalable, really large system. Now, those are coming, but if you go in that direction, you're kind of just bringing the past forward. So what we're really trying to figure out here with microservices is how do we really tackle some of these last tough problems? How do we take the complexity out of scaling? Now, definition of microservices, lots of them focus on the technology, right? It's about a certain style of API contract and things like that. Well, that's all true, right? It's about single function modules. And it's about well-defined interfaces. But I think the most important thing here is about how you change your team dynamics. Because the things that last a long time and the things that scale really well usually had an elegant architecture behind them. And they actually had very, very well-defined points of integration that teams could figure out when that next challenge comes along. How do I adapt this thing? How do I make it handle more transactions? And it's really about that small team dynamic. It's really about the people, right? That's how I look at a microservice architecture. If you can take all the pieces that make up a complex solution and you can identify the smallest number of people that owns any specific piece of it and really owns it, are super passionate about it, right? They know the ins, the outs, the transaction rates coming in and out of that component, and you reduce the scope of what they need to worry about down to something they can control in their code, then you've probably landed on a good microservices architecture, right? A lot of people know it when they get it. They know it when you've got your application broken down into 20 pieces, 20 teams work it, and those 20 people are super passionate about that one piece of it they own. And they no longer worry about whether the other 19 pieces are going to work, because they've actually built a model of interaction based on APIs, based on assuming failure, based on a bunch of other kind of principles, and it reduces the number of things they need to worry about. Now, I'll use an analogy. So, said differently, if what we're trying to put together is, a bunch of buildings, right? It's made up of a lot of pieces. It takes a lot of specialized tools to build it. Now, without, kind of organization, this is not a fun thing to dig through and try to figure out how do all the piece parts of this thing actually go together, right? Without structure, these are also really not fun to step on. I'm sure there's a few people in the room who've done that. But when it's just kind of like laying around and it's a jumbled mess and like everything can like touch everything else, that's not an architecture, right? That's the piece parts. Maybe you'll be lucky to structure your teams to put it all together and actually deliver the building at the end of the day. But it's more likely that you kind of need to step back and say, I need a different approach, right? I need to organize these things into their functions. I really need to break this down, and I need to think, okay, if I put all the gears together, then maybe I can build the motor. If I put all the struts and blocks and whatever, then I can build the walls, right? And then I can put the elevator and some of those blocks, out of some of those blocks and some of those motors. So microservice architecture is really kind of that magical definition of what are the piece parts and that are well defined that a small team can actually act on. Now, I'll use a different example. I could use Woodside, I could use American Airlines, who we work with, I could use many, but I'll just kind of pick a generic one and say, okay, if there's pressure on you to take, and this is a very, very typical scenario we see right now, there's pressure on you to take something that your business already does, bring it to a new market in a mobile way with a digital customer experience, right? Most of the systems we built for the first 50 plus years were back office systems meant to be operated by a trained specific operator, right? The bank teller in a bank, for example, the travel agent in a travel desk. Most of the systems we're asked to build today are intended to go and be used by people with no training in the back-end system, right? Zero training, right? Everyone here has watched their niece, their nephew, their child, their grandchild pick up an iPhone and just use it, right? Or pick up an Android phone and just use it, right? That's the level of intuition that we expect in this front-end experience. Now, building that's not simple. We have to take everything that was built for a company and figure out how to put a new front end on it that is engaging, social, and intuitive, right? So we're going to take that application. In this example, we're going to say, okay, let's take an application. It used to just be a travel company or a car rental company or a flight company, but now I need to bring people experiences, right? It's not enough to sit back and wait for someone to come in or call my phone number or happen to trip across my website. I actually need to engage them. socially and mobile way, very intuitive. And to build something like that out of the piece parts that you already have is actually kind of tricky. So you start to take it from, the front end of it back, right? Building a UI. We know how to build UIs. Lots of people here. Anyone here built a web app in the last maybe 20 years? At least, yeah. They're slowly going. Don't be ashamed of it. It's a good thing. These are good things we built. But as you start thinking about, okay, well, how do I actually bring all those pieces together, right? I'm not just bringing the itinerary and the booking system. I'm also being asked to make this thing social. I'm supposed to personalize it, and it's supposed to be intuitive. And I have no idea whether it's going to be at 2 in the morning, that's my peak load, or 1 in the afternoon. So you keep kind of breaking this problem down until you get well-expressed things. I probably could have given this same speech 10 years ago at an SOA conference, and that part of it hasn't necessarily changed, right? Good design, good APIs, good services. The thing that has changed is that technology enables every one of those blobs to be built by a different person, a different team, and deployed on a different architecture, right? We've actually kind of made the promises of 10 years ago real. Now, one of the default technologies most people pick, great, I'm in charge of one of those little circles. Let's make it a container, right? Anyone here heard of Docker? Fantastic marketing, isn't it? I mean, that took a technology that has existed in the Linux kernel since like the turn of the century and made it approachable and consumable and has done more to standardize application deployment packaging than anything else we did. That is an awesome whale. And it's been really fun. I've been one of the people at IBM working with Docker through this journey. And it starts really simple. It's like, wow, that was really easy. That container, I got my app part built, I got this API built, and then I had another container, and my next microservice is another container. And you think, okay, I got 4 or 5 of these things. This isn't bad. They all work. I can deploy them all. And then everybody gets into it, right? Wow, I got a lot of containers. Now, this is the kind of chaos that we're kind of seeing in most companies now. The neat thing is, there's more than a few technology companies that have been dealing with this technology for a while. And out of that kind of chaos, a lot of them said, you know what? We know how to organize these things, and we know how to build a distributed control system. Docker was pretty amazing what it did to the mindset of the developer. What we started to see now in terms of an open source technology that is changing the way we organize, deploy, and manage applications, Kubernetes has formalized a ton of those concepts, right? So this is about regaining control, right? Awesome. If you've gone and told all your developers that Docker is the way to go and containers are the thing, and that's how you're going to modernize your development, and that's how you're going to accelerate your pipeline so that you can go from coding to deployment in a very fast way, you've solved a big chunk of the problem. But right around the corner is that challenge of operationalizing all of this, or bringing it to operations, and kind of figuring out with all of these piece parts of the application, how do I bring them back together and manage them? Now, this is a technology, at IBM, we spent a lot of time looking at this problem, right? And it's not the only technology in this space, right? It is the one that we settled on for our own container service, but I'd actually say it's not the only microservice platform that we either built, offered, or decided was really cool. Now, the reason I'm talking to you mostly about, what Kubernetes and a few related technologies will bring to you in this next phase of your journey is because it fits a very special place. There are 2 other large projects that are related, different, but still enable microservice-based development. They just enable maybe a different part of it. The fastest and most prescriptive architecture that I've probably seen for building web applications is Cloud Foundry. Microservice-based, built on microservices itself, makes it really super simple to package web applications. So if the challenge that you've been given is, hey, go find the fastest way to deploy, version, update, rapidly test, do blue-green or some kind of pattern of test deployment of new web app experiences, there's probably nothing faster, simpler, more approachable than Cloud Foundry. It's very opinionated, though, about how to build, what we call a 12-factor application, right? How we build something that's completely stateless on the front end. How we actually do the traffic management between the two front ends of your web app. It's all kind of built into that architecture, right? It's a really awesome way of building the front end. Where it struggles as an architecture is how do you build the back end, right? Maybe they didn't ask you to build the front end of the service. Maybe what they said is, we need you to renovate our reservation system. That's a much more complicated thing. It's kind of got some process bits to it. It's got some data statefulness to it. The life cycle of what you're building is not a stateless front end, right? And that's kind of where Kubernetes comes in. And the last piece, a little more emerging technology, is on the serverless side, right? Event-driven architectures. Probably the neatest use cases I've seen in this space are people who realize that a massive number of our business processes today are about events that happen around pieces of paper, whether that's mobile check deposit or home loan or applications for government processes. A lot of them are just events around objects. And when you think about those three models, you actually realize these actually work together, right? This isn't like, I only need one of these. I've got one Kubernetes that is a generic microservices framework. I can build all kinds of stuff with it. I've got another one that helps me with a very opinionated view of how to do front-end development, web development, API development, and I've got another technology that's very focused on events, right? You will probably find in time you may need pieces of all of these styles of programming as you start to do some renovation. But the reason I'm just going to kind of major on the one related to Kubernetes today and what we built in the IBM container service is we've actually found it's the one that helps people do the most heavy lifting of what they already have. And how does it do that? I mean, most people know the history of this, right? It came out of the Valley here. It's got contributions from IBM. It's got a large amount of code from Google, inspired by how they run at scale. That's a pretty big, at scale company, right? And the things they figured out that not every developer should build or worry about, right? Scheduling. What should go where and when, right? They built the framework for that into the Kubernetes architecture. Self-healing. If I'm supposed to have 10 of these, I should always have 10 of these, right? If it's 10 API endpoints to my reservation system, the system itself knows there's supposed to be 10. If one of them is starting to fail or indicate problems, get rid of it and launch another one. A lot of people talk to me about auto-scaling. They think that the scaling part of auto-scaling is the hard part. It's actually the stability part that's the hard part, right? Building a system that can serve consistent volume in a healthy way is actually the instrumentation you need to build. Once you've built that, the horizontal scaling part is actually not hard. But building a framework that actually instruments each component and knows if it's healthy or not and keeps a certain number around is the tricky part. Because as you start to introduce change into that system, and if you kind of look at the bottom left, another kind of key thing to think about when evolving to microservices is how does a service find the other service, right? I've personally written 2 whole specifications on service discovery. And this is by far probably the simplest we've seen in terms of implementation now. Also just part of the open source framework. That enables automated rollout and rollback, right? As long as you can find an equivalent new endpoint for your interface and it binds very quickly. And in this case, it's built and underpinned not by a big complex protocol, but it's underpinned by things like DNS, reasonably well known and proven. The internet still works today, so we know it still works. And then the last part of it is all of that requires that you have a framework for configuration management, right? Now, I say we're going to talk about microservices and the evolution and tool selection today. You could look for another framework like this, right? Or you can pick one that someone's already built and open sourced. We kind of went the second path, right? Now, there's some things that are still tricky, things that we had to do to offer this as a service at scale, right? You end up with lots of clusters, right? Kubernetes is all about managing clusters of work. You can simplify that. It doesn't need to be command line. You can put a UI around it. These are the kind of things that we spend some time adding on. Security and isolation, right? It knows you're running containers. There's default policies, but there's a lot of work to do in this space, right? And this is a space where IBM innovates. Many other companies are continuing to innovate as well. Making it easier to just design your own cluster, right? What runs Google is not going to be the same as what runs an airline is not going to be the same. I mean, you do need some flexibility in designing these things. We went with t-shirt sizes, kind of the same analogy we did with virtual machines. So there's some pre-building that you can do. And then integrating this into operations, and I'm going to talk a little bit more about that in a minute, and leveraging other services, right? You don't need to rebuild database as a service, right? You can just leverage it. So we figured out the same way we did with Bluemix and Cloud Foundry, that you can introduce this concept of stateful services like storage and database and message queues and so on, and make those services that show up in this microservice assembly environment. But last and probably foremost in terms of things that we did consciously as a company is we actually kept the native Kubernetes open source experience, right? And that was an interesting thing because we actually had our own custom container service 2 years ago. And it was good, and you could do one container at a time, and we loved it, and we were proud of it, and we fed it, and it's like one of those little like digital pets. We kept feeding it, and people were, you know, slowly adopting it. But when we realized, going back just one screen here for a second, the back interface doesn't work. That's all right. Just remember the last screen. What we realized is that people just wanted that standard way of doing workload scheduling because it's a training investment, right? Once you figure out how to do this, it's no different than training a network operator or training a database administrator. These concepts don't need to be different, right? So training people on them, on how Kubernetes did them, was something we started seeing more people be comfortable with and familiar with. And so that was sort of where we hit that point. We said, well shoot, we're well over a year into development on a container service on our public cloud. What should we do? We said, well, you know what? Kubernetes has got this cool microservice architecture, right? You can run Kubernetes on Kubernetes and manage Kubernetes with Kubernetes. And that's saying Kubernetes a lot in one sentence. And we thought, how long could this take? November 2016, we put a team together. December 2016, we had a prototype. February 2016, we had an alpha. End of February, there's 2017, we had a beta. And we went general availability 2 months later. We built an at-scale public cloud service in less than 6 months using the architecture of the thing we were building on. Right? And to us, that was the proof point of like, you know what? We're onto something here. Right? This is actually pretty robust, pretty cool, and we can move fast with this thing. Right? All right, now, what doesn't come free? Connecting all your things is not free, right? It knows about containers. It doesn't know about application protocol. For any OSI people in the room, it doesn't know anything about layer 7, right? Like this is like, it knows you're spinning up and spinning down processes. It can keep them stable, it can keep them running, but it can discover them, but it doesn't tell you how they connect. And how they connect can matter. It also isn't prescriptive about what management means to you. It doesn't prescribe a set of DevOps tools, and it doesn't prescribe a set of operations tools. And those are also obviously things you need to run a production scale application. And last, it is not prescriptive about security. It enables security frameworks to be added on, but it doesn't actually come with a robust one, right? Now, these are pretty fundamental things, right? And we looked at this and said, well, gee, why don't we solve some of this too? And why don't we solve it in a standard way? So we said, you know what? More than just the underlying framework that keeps all your containers up, let's build a service mesh. What do I mean by a service mesh? I mean, it's a network about services. It's not about a network mesh that moves bytes around. It's not about a container mesh. It's a network that understands I've got a bunch of endpoints, and these are important, and they mean something, and they have to talk to each other. And it adds a bunch of characteristics around management and security and policy that aren't kind of just built into a standard microservice architecture. Go figure, we open sourced it, right? So, anyone here take a lift here today? Couple people? All right. So, the front end of Lyft you used today if you ordered a car. Nice little thing called Envoy, some code from Google, and some security code from IBM. Istio is a framework that works together with Kubernetes and starts to add that next layer on it. Right, so again, we're standardizing and open sourcing the whole next layer up. It's about sailing and Greek. There's this whole nautical theme with the container community. They just stick with it and they roll with it. So, if you're going there, get ready for lots of nautical analogies. Wear a sailor hat or something. Pirate hats are good too. And the things it brings this concept of routing and load balancing, right? Not just let the traffic flow, but manage the traffic, right? I want awareness so that when I change out a component, I want to make sure that it steers the traffic actively away to other components that are stable and up, or the new components, or do that 10% split. It allows you to do those kind of things. It gives you standard policy expressions to do those things. It also adds a bunch of critical hooks around telemetry and reporting. So it gives you that ability to add on top of it application specific. It's not about Kubernetes health anymore. We can take care of that. This is about your application health. This new thing you've been asked to build and build at speed and handle scale. Can you give me a view into that that is specific to my application? Right? This is a pretty powerful set of things that have come together under the Cloud Native Computing Foundation, right? It's actually been pretty fantastic to see, Linux, which kind of underpins all of this way down at the bottom, has actually played a leading role in bringing this forward. Now, 3 things to be aware of. Your APIs matter. They mattered 20 years ago. They matter now. They really matter now, right? So consider a technology that helps you manage and govern your APIs, right, as you go down this journey, right? It really, really matters that those are the contracts. All of that plumbing I just talked about will fail if you are sloppy with your API governance. The second one, give people a tool chain. When you go down this path of rapid change being part of your culture, you actually need a tool chain that is very different than the build system your company may have bought 20 years ago, right? You need something that enables collaboration, that enables instant testing, and all that kind of stuff. So this is one, you can actually go, if you look up IBM DevOps Open Toolchain, you can see an example of a click to deploy thing that wires all of this stuff together. And you'll actually see that other than the 2 things in the middle, none of it is our technology, right? We totally recognize that this stuff needs to be pluggable to different procurement decisions. So this is all intended to give you operational visibility. All right, here's my bad pun. You don't need to lose your head over this stuff, all right? There's a lot of challenges on this journey. What I would say is, if you really do microservices, yes, you're going to look at a lot of new technologies. But really what you're looking at in your development is actually culture change, right? So make sure you've got a plan for API governance. Make sure you've got a plan for operations. Don't just stand all this stuff up. Make sure you've got a plan for how the tooling enables your team to change things, right? And I think you'll be on a good path, and you can probably build something pretty cool from microservices on microservices. I just think this thing's cool, but anyway, and it fit my analogy. All right, with that, I just want to say, hopefully the why now part was obvious to you, or you probably wouldn't be here. But the technologies are there, the frameworks are there. There's a massive, vibrant open source community, right? So this is not just a vendor thing. This is, a change in how we will build the next generation. Every one of these is a rapid moving community. They have a DevOps culture, and all of this technology was born in the last few years on cloud. So with that, I want to say thank you. I hope you have a fantastic conference, and I'll be here if you got any questions.